In this video, we're going to continue our discussion with section 5.1 that has to do with polynomials, and specifically in this section, we're going to continue to talk about finding, identifying, and using zeros to help us solve our problems. Okay, and so the problem that we're having right now, or the skill that I want you to build, or the thing that we need to do is to graph a function. Okay, so and in graphing the function, or to graph the function, we need to use the x-intercepts, which are the points at which y is equal to 0, okay, of the function, and that's going to help us graph the function. Okay, so that's enough of that. When a zero occurs, okay, when the line crosses the x-axis, there are two possible reasons. Okay, the graph touches the x-axis, or it passes through the x-axis. Okay, if the zero has an odd multiplicity, then the graph passes through the x-axis, and if it's even, then of course the graph only touches the x-axis. Okay, so keep that in mind when you're doing mathematics by yourself in your room, to remember to keep things straight. Okay, so let's look at identifying the real zeros, okay, or graphing the function based on using the zeros that we found in our last video. So this is the same function. We can call this f of x, okay, and we want to solve, or we want to graph this function, but first we're going to use the zeros to do it, okay? And so to do that, we need to remember what those zeros were, and the zeros were 0, 0 with multiplicity 2, negative 2, 0 with multiplicity 1, and 1/2 0 with multiplicity 4. Okay, so here and here, it's just going to touch, and here it's going to cross. Okay, and so what I mean by touch is if my function came down here and then touched the y-axis, but then came back up, then this would be the touch there, okay, touching the y-axis. But if it crossed the y-axis, then that's of course crossing the y-axis. Okay, so let's see. It happens. The points that we know are on this function, okay, or our solutions to this function, are 0, 0, negative 2, 0, and 1/2 0. Okay, so I'll put a smaller dot there as to not overcrowd what's going on. And so, to graph the function, now we have this. We know that it's going to cross at negative 2, 0, and then touch, and again touch at 0, 0, and 1/2 0. So now to get the position on the graph, what we're going to need to do is just substitute in some numbers and see if we can get values back. So for instance, let's substitute in negative 3 to the function f of x equals 5x squared times x plus 2 times x minus 1/2 raised to the 4th power. Okay? So if we choose negative 3, okay, what we have is 5 times negative 3 squared plus negative 3 plus 2, times negative 3 plus 2 times negative 3 minus 1/2 raised to the 4th power. Okay, and so we get negative 3 squared is 9, and 9 times 5 is 45. Negative 3 plus 2 is negative 1, and then negative 3 minus a half is negative 3.5. Raised to the 4th power is going to be some large number, way far off this, okay? And so when I multiply these together, I'm going to get an even bigger large number. And so what's going to happen, and that's just here at negative 3. So what's happening is that it's a really large number that's going to come down and cross at negative 2. Okay, let's try negative 1. Okay, negative 1. 5 times negative 1 squared times negative 1 plus 2 is negative 1 minus a half to the 4th. So that's 5 times 1 times I'm sorry, doing some math here very quickly. That's negative 1.5 raised to the 4th power. Which is 5.06. I'm sorry, this is, I just realized a mistake. It's not coming down from the top. It's coming up from the bottom. Okay, this makes it a very large negative number. So we're coming up here. This is times 5.06 something. So that equals out to be about 25. And so we shoot up very quickly all the way to 25. Actually, it's probably just better to get rid of this. It's going to be straight up to negative 25. Then it's going to come down at 0, so it has to peak sometime up here. We don't quite know when. But it's going to come down and hit 0, 0, but it only touches. It doesn't cross. So then it's going to go back up. Okay, but it's going to need to come back down and touch again at 1/2. And then after 1/2, it's then going to again explode up in that direction. Okay, so these involve huge numbers, this equation, and so it's going to be really hard to graph that function, but we know that it crosses here and touches there and there, and that's the really important part. Okay, so here's a much more manageable function. I want you to graph the function 3 times x minus 7 times x plus 3 squared, okay, using the zeros method.